This is a little extra video about making assumptions in our Ka expressions. So in the last problem, we saw hypochlorous acid forming hypochlorite base ion and H3O plus. And we did a Ka expression like this. We were trying to find the pH of the solution when we had 1 molar hypochlorous. So our Ka is equal to So when we're thinking about these chemical equations, we can actually think about this in terms of moles and not molarity. And if we're thinking about it in terms of moles, we can actually think about what are the molecules doing in this reaction. So before an equilibrium happens, we have, according to our problem, 1 mole of hypochlorous acid. And I know this because if I've got 1 molar, let's just assume that it's 1 liter. We've got 1 mole, and after equilibrium, we create some amount of OCl minus and some amount of H3O plus. And you might be saying to yourself, well, if I'm creating stuff over here, that means I have to be subtracting over here. So what we can do in chemistry, what you see is that you make an assumption that this subtracting of X from our hypochlorous acid is so negligible that it doesn't matter. And that's where you make this assumption. So if we want to write out a full Ka expression for this, it would look like this, where this is X times what we don't know, and it's 1 molar minus X, because that's how much we are changing from our hypochlorous acid into our 2 products. But this makes the math really confusing. For this expression to happen, you have to solve using the quadratic equation. And so for the most part, we can assume that this change is so negligible from how much is in this 1 molar that we don't even need to calculate it. And the way you can check your assumption is this. When you find the concentration of H+, you can divide it by your concentration of your original acid. And if we multiply it by 100, and this percentage is less than 5%, then the assumption is okay. It's okay what you did. It's generally so negligible that it won't make any difference in the H+ concentration. But if your assumption is not less than 5%, then you must go back and solve using the quadratic equation.